Hi, welcome to DIYDSP.com, and here is an update on some of the things I've been working on lately. First, I'm going to hit you with a little bass line. That's from Pyramid Eel 1, which you've seen in some of my other videos, and now I'm working on Pyramid Eel 2. This is the master CPU, which is half of a gigahertz with a floating point supply. But today I wanted to talk about some current measurement, because that's going to be one of the newest things added to this eel that I've always wanted to ever since it was first designed. So this here is one of the first current measurement boards that I made. It had some interesting features in that there were two poles of a low-pass filter you could configure, and it had some ability to offset. And it was based on a Hall effect sensor. So what I learned since then is that my currents are not large enough that I need a Hall sensor, and also the current ranges that I'm using are not high enough to be used with a current sensor. So this one unfortunately has a very low gain. It could be possibly worked on, but then when I found out it had huge offsets, I got frustrated and I gave up with it. And then I switched to this. Here is my attempt to make a classic differential current sensor using an op-amp and a shunt resistor. A tried and true approach. Instead of using that current sensor, I could potentially choose the gain and everything. The only thing is, when I went to go and research this, I discovered that new ICs are now available that have many external components inside of them. They also have some other advantages, such as having some EMI low-pass noise filters inside as well. So here I made a basic test of this just to observe the current the voltage differential under normal operating conditions, which are pretty much plus or minus an amp max, much more often in the 500 milliamp range, through these 0.1 ohm resistors. There are two different circuits here, one for the generator and one for the speaker. So when I went to connect the op amps and learned just about what is new, I had to get rid of this. So I'm going to detach that very soon and hook up the next thing, Generation 3. Okay, this here is an evaluation board for a current sensor from ST Microelectronics. So that kind of additionally gives me a good feel that it'll work well with a lot of the processors I use, because I love the STM32 ARM series, all the 32 bitters, from the F4 to the L4, now up to the H7, and many other friends along the way. So this is an eval board that lets you eval this chip here. I believe this came with the TSC2011. So these are the different gains. They're not even configurable anymore. So if you can deal with the fact that your gain is either 20, 60, or 100, then you can make use of this. So the other nice thing about this this chip and using this over some of the other circuits is that you can actually have a 50% offset just by setting this VREF pin here. I'm going to have to check the spec sheet just to see exactly how to configure the jumpers, but that's good for bidirectional voltage measurement, or bidirectional current measurement in this case. So in my system, there's a unidirectional current flow from the rectifier capacitors into the H-bridge amplifier, and then from the amplifier into the speakers there is a bidirectional current flow. So strictly speaking, the bidirectional current flow doesn't have to be measured, but it's going to give us a lot better idea how things are flowing, because the speakers, of course, are very reactive load, whereas we're only going to see the real components before the bridge. It'll just help with the state estimation overall. So I'm very excited to hook this up, and when it ordered, I was so excited I sent it to the wrong address. I vertauscht. I swapped the digits on my own address. I was just so excited. And then, of course, when it arrived, it went to the wrong house, got sent back to UPS. I had to drive all the way, about half an hour, to the UPS warehouse to go and pick this up. And then there was a huge line. They only had about 1 or 2 people working there. So there's a huge line. And of course, it's the pandemic, so everybody's waiting outside in line. And I was just motivated enough that I did some core strengthening exercises while I was in line. So I made the best use of my time, but it was upwards of an hour. And I was very happy when I was able to pick up 3 of these current measurements. And then only to have my Hope's Dash one, and take a close look here. This is where the sense resistor connects, right? RS. So it's depopulated. So for some reason I had assumed it would come populated. And then I thought to myself, well, I can get a sense resistor, but you know, who wants to order a 5-cent resistor from DigiKey and pay $7 shipping? So I had some stuff to return at my favorite store in the world, You Do It Electronics. And so I went down there, and the only trouble is they don't really have many chip resistors, if at all. And while these new components are awesome with their gain of like 60, you need some pretty small resistances. So the good news is I was able to buy these. These are the smallest resistors I could buy in a retail store. So take a quick look at those, and I'm going to get the calculations out. So just real quick, it's all based around this current flowing through the sense resistor. So if you label everything IRS for our sense and consider the voltage of the sense there, there's going to be the voltage that you actually measure. So because of the gain, the voltage measured is going to be 60 times the sense resistor here. So you can work those equations around and come up with what range you want. I settled for now on 1 volt per amp. That's going to enable me to get 1 amp in either direction at least, maybe even up to 1.5 amps in either direction, which is a little more range than I need, but it's enough to get started with. And you know, when I need more accuracy, I can get it. And so if you solve the equations here, it really, it actually calls for, and you can only fill in a couple values for gain, right? Because that's fixed on the chip. I think we had 20, 60, and 100, and then the dev board only comes with the 60. So I would love to go further and increase that, you know, to 100 at some point. Even better, I watched a tutorial and they said that there is a significant difference between high side and low side current measurement. And this is a high side only because I wanted to save some time with the dev board. So the goal for the next rev of this is going to be to have an additional low side current measurement. We get something like 3 or 4 more bits of accuracy. For people who think in decibels, that's about 18 to 24 more dB at least. It might even be 5 bits. Nothing to sneeze at all. But, you know, it's just I don't want to design another board. I'm already designing so many boards, and that's one of the longest poles in this whole entire stupid project. So long story short, the good news is that with a gain of 60 and I want 1 volt per amp, I'm going to, the recommended sense resistor is a 1/30th of an ohm, which is 0.03 repeating, so 1/10 of a third. So why is that so exciting? Because look back at these resistor values. They're 0.1 ohm. So that is about 3 times the 0.033 required, right? So how do we make a 1/30th of an ohm from a 1/10 of an ohm? I'll wait, think about it for a second. How do you, if you have 0.1 ohms, how do you get 0.0333? Just as a hint, when you put 2 capacitors or 2 resistors in parallel, the resistance goes to half, right? Well, here when we put 3 in parallel, then it's going to go to 1/3 of a 1/10. So that equals exactly the 1/30th of an ohm. I'm pretty excited. That's really like the main motivating reason I'm making this video. I mean, I'd love to make the progress updates often, but sometimes I think the results are, you know, kind of minor. But this is pretty exciting. This means I'm going to be able to snip those right out of the package, put them right onto this dev board here, and hopefully get some results pretty soon. You know, there's basically nothing else to order, and this is, other than using the low side, this is the highest quality. You know, I wish I had time to get into, but there's tutorials in how differential resistor networks work, and also this is a very small package. It requires very few external components. I'm going to have to check the schematic just to see what those couple of, there's 3 capacitors on there. I'm sure they're for some kind of noise reduction. I don't know. But yeah, so this is going to plug right into my circuit, and I'll be able to measure it with my scope. So anyway, yeah, if you enjoy seeing how the sausage is made, how I'm designing these electronic instruments sort of in tutorial form, or if you want to be a player of the instruments. I definitely need players, and I'm trying to design things as fast as possible. And I just like to share the joy. Then definitely like this video. If you like this video and you've never liked any of my videos before, there's a special note on it that tells them that's the video that got people to subscribe. So go ahead and subscribe as well. And I'm even starting up a Patreon, so go look for me over on Patreon and get some more amusing type of in-depth content and a lot more previews of playing and stuff like that. All right, thank you very much.